who are kind of very aware of certain SOA principles, that they do find it difficult to make sure idempotency and retrace are built into the system. It comes at a cost, but then it makes the system behavior far more reliable. And the next practice I want to talk about is asynchronous scaling, is what we do. So most of the time you, I mean, if you're familiar with any kind of queuing protocol, JMS or internal queues, anything that you're doing proprietary within your own stack, anything that you can do in an asynchronous fashion, you do it. This is not a new paradigm either. Like even if you're doing a front-end web flow, right? So JavaScript is a classic example. Right? So Ajax is classic example. So you try to do as much as you can, depending on the user experience, the product experience, as much as you can in an asynchronous fashion. To send out an email, you should not be invoking an operation. Right? You can, but if it is through a queue, right? So it's through an internal queue, it's fine. So you try to keep your existing systems as trim as possible and try to move as much as you can to the asynchronous world. So you try to push as many messages as you can. So if you want to monitor the risk, if you want to monitor the recommendation engine on an e-commerce site, example being somebody was buying baby items, they tend to buy more. You don't have to, immediately inform. It need not be a synchronous call to the recommendation engine. You can inform the recommendation engine, whatever they are running behind the scene, the risk engines behind the scene through, messages. But there is a caveat though. So I'll just go down to that as well. So some of the more popular one that open source compliant is AMQP. That's blessed by the Apache community. So there are a couple of implementations: RapidMQ, OpenAMQ. So not all queues are identical. So if you look at the RapidMQ implementation versus OpenAMQ implementation, yeah, it meets the specifications, but there are certain what should I say? Certain intricacies that you have to figure out. So so you have to know the system. So it's not like, yeah, I got a queuing system, I know this is what it's supposed to do. This is where kind of the road meets the rubber, right? So you have to understand, you cannot be hand-wavy beyond a certain point. You have to understand why you're choosing certain queuing protocols and what you get and what you don't get. So, and the reason is this. Traditionally, when you look at any classic e-commerce that's taking reasonable amount of traffic, or any system that's taking reasonable amount of traffic, you are firing a lot of messages. You probably are firing roughly, depending on an average, you're probably firing, 500K messages per minute easy, depending on what type of systems you're running. Sometimes 500K even per minute or per second, right? So asynchronous scaling cuts you in both ways. It's really good at scaling, but you have to get it right. So you have to make good choices. So it depends, again, it depends on certain amount of experience that you want to have, whether it's persistent or non-persistent. A classic example that's always thrown around in terms of queuing is a stock code, right? So if I'm interested in, say, stock of Google as of now, but then the stock, it keeps changing. So I get a message that's 400, say it's 400 rupees now, but then it moves to 450, and again it moves back to 475. For whatever reason, I didn't get the 450 code, but then when I look at my app, I end up getting 475, which is fine because at that level, as for that particular application, you are fine with the most recent code. You don't need all the previous history of codes, right? So at that point, maybe you are fine with picking up a non-persistent queuing mechanism. But that will not work for example, when you're going through a user sign-up, right? So user sign-up means you have to inform risk of something. You have to send an email out to the user. Otherwise, it's a bad user experience. So in that way, it's not like, oh, you can drop a couple of messages here and there and you can move on. No, in certain use cases, you cannot afford to drop messages. So you have to figure out, what type of a persistent queue you want to choose. And then when you're choosing persistent queues, it's like you have to figure out the retention window, whether you do like a 14-day retention window, 21-day retention window. What we mean by retention window is even if your subscriber goes down and the subscriber comes back up after X amount of time, the subscriber should be able to process that message. So even you're publishing something to some engine to send out an email and that engine is down, if it comes back up, it should be able to get that message back and then send that email out to the user. So for certain behaviors, you have to make certain choice of queues, and you have to be careful of what you choose. It's all driven by the product experience as well. And so most of the time, the other thing that you have to, if you have a subscriber, it's better that if you're building something that's taking huge amount of production traffic, you might end up getting messages that are the same, like, that you might end up getting the same message again and again. And you should have the ability to figure out, okay, this message I've already processed and this one I haven't. So it will be great to have only once exact order messages, but it is really tricky to get those type of queuing protocols. They do come, but you have to make a lot of customizations. It's expensive to build that out. So as I said, because you're firing so many messages at a given time, queuing protocols normally it's like there is no the implicit assumption is all messages are successful. Only on failures is the rare case, right? So normally when you're firing say 500K messages per minute, you don't want to realize that something is wrong after 2 or 3 hours. So you probably want to realize that something is wrong within minutes of within minutes of something failing. So even when you go back to RabbitMQ, what are the queues that you decide to use? Sometimes you might have to build custom clients. So the reason for that is when you are going through non-persistent queuing, the message does not even, there is a good chance the message has not even left the kernel stack or even the network stack, right? So it still hasn't even gone through the network interface card. But still the software comes back and says, yeah, done, message published, right? You can live with that behavior, for use cases like, stock, etc., etc. But you have to make sure, like, you get some kind of acknowledgement after you fire, say, 200K or 500K messages, that at least the messages have been reached to the broker and the broker is good to go, etc.